This question, we have a sled sliding down a hill, like so, and there is friction between the two, but no air resistance. And so there's no air resistance. What must be the correct change in energy of the sled Earth system? So what we of course know is that we have total energy of the system is going to be EPG plus EK plus, let's say, thermal energy that's created in friction. So at time zero, there's no motion. So at time zero, we have, and this is at the top, is going to be mgh, where this is h. The kinetic energy is 0 and the thermal energy is 0. Now let's go down to this new location. What has occurred during this time? Well, we have decreased the gravitational potential energy, and we have increased the kinetic energy. But since there's friction, we have also increased the Q. If there were no friction, it would be just the sum of these two, but we've now increased the Q. So let's see our choices here. The sum of the kinetic and potential energy changes by an amount equal to the energy dissipated in the friction. So let's see if we can make sense of that. So the sum of the potential and the kinetic here is just the potential. These two should remain constant, but some leaves and goes into Q. So the potential energy, the sum of the kinetic and gravitational potential changes by an amount equal to the energy dissipated by friction. That seems like that's the answer. So let's look at choice B. Gravitational potential energy decreases and kinetic energy is constant. Well, if we remember, potential energy is about changes in height, kinetic energy is about change in velocity. So if the kinetic energy is constant, then the velocity must be constant. Well, we know the sled speeds up from the very beginning, so this can't be true. B is out. Decrease in potential energy is equal to the increase in energy. That is true when there is no friction. But there is, so choice C is out. The gravitational potential energy and the kinetic energy must both decrease. In the beginning, the kinetic energy is 0. It's not possible for it to decrease any more than that. Now, while it is true the gravitational potential energy will decrease, we expect the sled to increase its speed for some period of time. So this can't make sense, and thus we verified why choice A is the best